It's October 30th, 2017 at 3:24 p.m. Eastern Daylight Time, our 1920 Universal Coordinate Time, and you are looking at a live view of a Falcon 9 rocket as it awaits liftoff from the SpaceX launch pad approximately 10 minutes from now. Welcome to today's live webcast of the Koreasat-5A mission from Launch Pad 39A at the Kennedy Space Center in Florida. My name is John Federspiel, and I'm a lead mechanical design engineer here at SpaceX. And today, we will be delivering the Koreasat-5A satellite to a geostationary transfer orbit, also known as GTO. Now, as with our previous GTO flights, we will also be attempting to recover our first stage via our drone ship, Of Course I Still Love You, currently stationed in the Atlantic Ocean about 340 nautical miles downrange of the launch pad. Now, we did have some rough seas due to a tropical storm that passed by the Bahamas in the earlier, but the drone ship is now on station and looking good for recovery. If successful, today's landing would mark our 19th overall successful landing. Now, today's launch will mark SpaceX's 12th from Launch Complex 39A and 16th launch overall this year. On your screen, you're seeing some footage of the SpaceX hangar located at the base of our launch pad. This hangar can house both Falcon 9 and Falcon Heavy, and in fact, our launch today for Falcon 9 was prepared right next to the 3 boosters currently in the hangar for Falcon Heavy, which we're targeting to launch by the end of this year. Koreasat-5A was mated to Falcon 9 last Friday and rolled out to the pad and raised vertical about 24 hours ago. This operation was done while the vehicle was supported by the strong back. That's actually what will separate, and the first stage itself will come back and land on the drone ship once it basically gets us out of most of Earth's atmosphere. The second stage, that's what actually is going to be doing the precision orbital maneuver. It uses a single Merlin engine optimized for the vacuum of space to place Koreasat-5A into the geostationary transfer orbit. Koreasat-5A is housed inside our fairing at the forward end of the stage. That's the area that's a little bit of a larger diameter and has that KT-SAT logo on the outside. About 3 minutes and 39 seconds into today's flight, we'll be separating that fairing, and it will fall back to the Atlantic Ocean as well. About T-minus 9 minutes into today's mission. Right now, all systems are go, tracking no issues at the moment. We began loading propellants at the T-minus 78 minute mark. Right now, we have finished loading RP1. That's our fuel for today's mission. We finished loading it on the second stage. We're going to top off RP1 on the first stage up until the T-minus 5 minute mark. We are currently loading liquid oxygen and sitting nearly full on both our first and second stages, and we'll continue loading liquid oxygen onto those both stages up until the T-minus 3 minute mark. We try and hold that to as late as possible because we cryogenically cool the liquid oxygen down to about negative 340 degrees Fahrenheit, and then we load it onto the stage so it's as dense as possible so we can get as much propellant onto the stages and give ourselves as much margin for the mission. Coming up at this moment, it's about T-minus 8 minutes. We did check out our spacecraft, Koreasat. They transitioned to internal power about T-minus 20 minutes. They've given us a go for today's mission, tracking no issues. We are also launching from Kennedy Space Center. So we are working with Kennedy Space Center team as well as the Cape Canaveral Air Force Station. They have cleared the area and secured it around Launch Pad 39A. They've also cleared the corridor leading out of the pad downrange and given us a go for today's mission. Looking at the weather, it's a beautiful, beautiful, beautiful blue sky, 65 degrees and sunny at Cape Canaveral, tracking no issues at the moment for weather. So with all stations indicating go for launch, let's take a little closer look at today's payload. Koreasat-5A is a communications satellite operated by KT-SAT. It's South Korea's sole satellite service provider. The satellite was manufactured by Thales Alenia Space and located at 113 degrees east longitude. Koreasat-5A will provide direct-to-home broadcast, broadband, and backhaul services with its Ku band capacity. Koreasat-5A provides KT-SAT with 12 Ku band transponders of 36 MHz and 24 Ku band transponders of 54 MHz. Now, as a replacement for Koreasat-5, Koreasat-5A will expand upon its coverage across Asia and the Middle East. And unlike other satellites in the Koreasat fleet, Koreasat-5A will provide maritime coverage of the Persian Gulf, Indian Ocean, South China Sea, and East China Sea. Koreasat-5A is also equipped with 4 extended Ku band steerable transponders of 54 MHz each. These steerable transponders will provide commercial direct-to-home broadcasting services in the North Asia region by the end of this year. The Koreasat-5A satellite arrived at SpaceX facilities in early October and has been undergoing preparations for its launch today. It weighs about 3,700 kilograms at launch and offers payload power of approximately 6.5 kilowatts. You're seeing that satellite getting loaded into its shipping fixture on the screen right now. That was brought into an airplane, shipped to Cape Canaveral, and arrived at the SpaceX facilities just in that transport crate you see right there. Now, Thales Alenia Space is the prime contractor for Koreasat-5A, in charge of its design, production, and testing, as well as the ground delivery. The company is also responsible for its launch campaign, the launch and early operations phase, and in-orbit testing of Koreasat-5A. Now, today we are taking Koreasat-5A to a geostationary transfer orbit. And on your screen, we have a quick animation. You can see the launch with first stage landing. That second stage has its first burn. After that burn, we have a fairing separation during it. We will coast for about 20 minutes. Then we're going to have a second stage, second burn, about T plus 35 minutes and 30 seconds. We're going to have our payload deploy. Then Koreasat-5A will use its own onboard thrusters, put it in a final geostationary orbit at about 36,000 kilometers away from Earth. You can see it's matching Earth's rotation. That's how it actually covers a singular spot of Earth's sky, and in this region instance, that 113 degrees east longitude position. So we're about T minus 4 minutes and 20 seconds in today's mission. As of right now, we're finishing up that LOX load on the first stage. No issues to report right now. The forward arms of the strongback have begun opening up. Everything there is looking good to report. It will fully recline at liftoff. At T minus 7 minutes, we began the engine chill process of our first stages. That's where we actually are flowing in that liquid oxygen into the first stage engines. That kind of chills down all of the metal components of the Merlin engines, and so that way they don't actually flash into gaseous oxygen at liftoff. It protects the engines and gets it ready for the actual ignition point. Coming up at the T minus 1 minute mark, Falcon 9 is going to enter into startup. That's actually the moment where our ground computers are going to hand over the countdown process to Falcon 9. The onboard flight computer of Falcon 9 will take over the countdown at that point. It'll do its final checkouts of all the sensors, which will lead us up into liftoff at T minus 0 mark. So, recapping where we're at right now, our payload is on an internal power, giving us go for today's launch. Our fairing boat is, our drone ship is out in the sea, 340 nautical miles, go for today's launch. Our rocket, Falcon 9, go for today's launch, topping off liquid oxygen right now. Weather's looking good, range is good. So at about T minus 3 minutes, let's listen into these final few minutes of the countdown process.
Stage one LOX is closed out for flight.
MVAC countdown 1, confirm TVC is nominal.
Stage 2 TVC motion's nominal.
Stillings will give the launch countdown. Yeah.
Stage 2 LOX is closed out for flight. Vehicles in self-line.
Gas closeouts are started.
AFTS is ready for launch.
Falcon 9 is in startup.
Gas closeouts complete.
Stage 2 pressing for flight.
LD on countdown 1, we're go for launch.
T-minus 30 seconds.
Stage 1 pressing for flight.
T-minus 15 seconds. Stand by for terminal count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Vehicle pitching downrange.
Stage 1 propulsion is nominal.
Power telemetry nominal.
T plus 50 seconds in today's mission. We are on our way to delivering Koreasat-5A to a geostationary transfer orbit. Watching the 9 Merlin engines of the Falcon 9 first stage.
Falcon 9 is supersonic.
Capable of putting out over 1.7 million pounds of thrust. About 5 seconds ago, we transitioned to the supersonic regime. Coming up in about a second, we're going to hit
Vehicle
max Q.
experiencing maximum dynamic pressure.
We actually just passed through max Q. That's one of the highest stress states on the vehicle. Propulsion avionics continues to look nominal.
MVAC engine chill has begun.
You heard the call out. The Merlin vacuum engine of our second stage has begun chilling in. Same process as the first stage, where we start to flow that liquid oxygen through that second stage engine. This first stage burn will last for about another 30
Recovery bird
seconds.
has AOS.
about 10 seconds, we'll have main engine cutoff. All 9 Merlin engines at that first stage will shut down. About 3 seconds after that, we will see stage separation, where the first and second stages will be separated by 4 pneumatic actuators, and then we will have the ignition of our second stage engine. Let's watch.
William, you go.
Stage separation confirmed.
We have vacuum ignition.
And we have a good ignition of the Merlin vacuum engine of our second stage. You can see the exhaust plumes coming from the forward view of our first stage on the left screen camera. Our grid fins have also deployed, as you can see there. We use those grid fins to guide ourselves back through Earth's atmosphere to our drone ship, Of Course I Still Love You. In about 15 seconds, we'll have separation of the fairing from our second stage. That's a view inside the fairing. Koreasat-5A on the right side. And we have separation of the fairing. It's a good separation.
Second stage is following a nominal trajectory.
And we have a call out that second stage is following a nominal trajectory right now. Everything looking good. Meanwhile, first stage is continuing to guide itself down. We're coming up on entry burn at about the 6 minutes and 23 seconds for the entry burn. Now, in addition to using those grid fins for guiding ourselves back to the ship, we do have cold nitrogen thrusters. That's those white puffs of smoke you see coming on the screen on the first stage image. We also use that to help orient the stage back to the drone ship. Our second stage burn is going to last till about T plus 8 minutes and 30 seconds. Then that second stage engine will shut down. We'll be coasting for about 20 minutes. And then we will have our second burn to put Koreasat-5A into the final geostationary transfer orbit. Entry burn coming up in about a minute for the stage one. It passed through its apogee of about 110 kilometers. So now we are accelerating back to Earth. We use that entry burn to negate a lot of the vertical velocity that the rocket is built up and help slow down the entry speeds, so a more gentler touchdown. Entry burn will be about a 20-second entry burn. We're using a combination of 1 and 3 engines, depending on different timing and sequences of this burn. Today, there is only 2 burns since we are landing on the drone ship. We're not going back to Cape Canaveral. So we just have the entry burn followed by the landing burn at about 8 minutes and 6 seconds.
Drone ship AOS.
Stage 1, AFTS has saved.
Stage 1 entry burn has started.
Confirmation of entry burn start. 20-second burn.
Stage 2 continues to follow a nominal trajectory.
Stage 1 entry burn is shut down.
And we have shutdown of the entry burn.
Expected loss of signal Cape Canaveral.
We'll have our landing burn in just about a minute of stage 1. Single engine landing burn. Now we may lose signal, as you saw there briefly with stage 1. We are getting the feed from a satellite in the drone ship. With that tropical storm moving through the area, there were some choppier seas, which makes our satellite link a little bit more challenging, but we will provide you guys updates as we have them. Meanwhile, you're looking at a live view of
Stage 1 is transonic.
The call out for stage 1 passing through transonic regime just came. Trajectory continues to look good for this second burn, or first burn of the second stage, which will have cutoff at about 8 minutes and 30 seconds.
Stage 1 landing burn has started.
The landing burn for stage 1 has begun. A 30-second landing burn.
Stage 2, AFTS
It's a live view from, of course, I Still Love You, our drone ship out in the Atlantic Ocean.
And we have Seco.
We do have confirmation while we're waiting for an image from the drone ship that we did have our second stage engine cutoff. But if you've tuned into past in webcasts, you've noticed that we have lost feeds in the past of our stage 1. Right now, we don't exactly know the state of stage 1, but as of this moment, it does look like we are in a good parking orbit for stage 2.
This is recovery. Stage 1 is landed. Recovery operators moving to section 1.
And we have confirmation from recovery operators that stage 1 has landed. Stage 1 has landed. We don't have any images and footage to share with you. Oh, there's an image right now. A little toasty, but stage 1 is certainly still intact on the drone ship. Our second stage is in a good parking orbit right now. So what we're actually going to do is leave you this animation of stage 2, so that way you can keep tracking its progress. At about T plus 26 minutes, we'll be back to cover the second burn of our second stage and put it into a geostationary transfer orbit. So we'll be pausing right now, and we'll see you back here at T plus 26 minutes.
Expected loss of signal. Acquisition signal, good morning.
T plus 26 minutes and 15 seconds into today's mission. If you're just joining us, we had a successful first burn. We have a live view of our first stage there on our drone ship. You saw it a little bit toasty earlier with some fires. Those fires are out. Our team is taking control of it. First stage is looking good, right on point in the center of Course I Still Love You in the Mid-Atlantic Ocean. If you look back at our primary mission today, second stage is coming up on its next burn. That will start in about 10 seconds. That's a live view from the aft end looking at our Merlin vacuum engine of the second stage. We're right now sitting in a good low Earth parking orbit. In about 2 seconds, you'll see ignition, and there it is. Ignition of our Merlin vacuum engine. This will be about a 1-minute burn. That burn will take us into a higher apogee. This is what it's basically doing, is it's raising the apogee of second stage, getting ready to deploy Koreasat-5A into that geostationary transfer orbit. This burn, like I said, so far looks good. We will be executing this burn for about 30 more seconds. And then after the burn finishes, we will be coasting for about another 8 minutes, and then we'll have payload deployment. Right now from that animation, it's hard to tell, but we're off the western coast of Africa. Engine looks good, throttling down, and we have shutdown. And that looks like we are in a good geostationary transfer orbit. We have payload deployment coming up at about 35 minutes and 30 seconds in today's mission. So we're actually going to pause again, leave you with another animation of where our Stage 2 and Koreasat-5A are positioned over Earth. We'll be back about T plus
Good orbit,
35 minutes. Our GNC callout just confirmed that we are in a good orbit insertion for the payload. So we'll be back at T plus 35 minutes with payload deployment. T plus 35 minutes into today's mission. You're looking at an animation of And with that, we had a successful landing of our first stage, albeit a little toasty, but it's certainly intact and ready for another flight on our drone ship. Of course, I still love you. We also had a successful deployment of Koreasat-5A to a geostationary transfer orbit. So with that, we're going to conclude our webcast. We would like to thank our customer, KTSat, for today's mission. We'd like to thank the United States Air Force for supporting today's mission from the Cape Canaveral Air Force Range, as well as the FAA for their support. And most importantly, we'd like to thank you, the viewer, for tuning in for today's mission. Please keep apprised of updates on our social media platforms, Facebook, Twitter, Instagram. We have a few more missions coming up this year. And if you'd like to come up here and join the team that makes all this happen, check out spacex.com/careers. Thanks again for tuning in. We'll see you next time.